Hello, this is another video for AP3, and today we're going to talk about geometry and trigonometry. The question shows the following. Yara is folding a paper crane using a piece of square original paper with a side length of 6 inches. The first fold she makes is along the diagonal of the square as shown. What is the length of the diagonal line folded in inches? So what do we already know? We already know that one side is 6 inches, and because we have a square, we can assume already that all sides are 6 inches. So 1, 2, 3, and 4, and they're asking what is the length of the diagonal line. So we have to use our right triangle rules. Now what do we know? We already know that we have a right triangle. We have a right triangle because both sides are the same. So we have 6 and 6, and we're looking for the diagonal line. Now what do we know? We already know that the line that they're asking for is the longest line, and therefore it's the hypotenuse. And the way to find a hypotenuse is using the Pythagorean theorem, which is a squared plus b squared equals c squared. So all we have to do is use this formula in order to figure out the hypotenuse of the triangle, or the diagonal line basically. So h would be c, and the both sixes would be a and b. So we would have 36 plus 36, which equals c squared, and then we will have 72. We have 72, and then we have to find the square root of 72. Now there's no number that multiplies together to have 72. However, we can break it apart in order to simplify the answer. So what we can do is that we can use 36 multiplied by 2, because 36, the square root of 36 is 6. So we can write the answer as 6 with 2 inside the radical, and this is our answer. Okay, let's do a triangle question now. Again, the question asks the following. What is the measuring degrees of QRS? So what do we know? We have a right triangle, obviously, with an angle of 5 with the square root with the 5 inside, and then 10 with the square root of 5 in it. And we know QRS, which basically means whatever the angle, which is like this, will be R. So over here. And they're asking us the angle of it. Now the only way to find the angle of R in this situation is using something called SOHCAHTOA. Or that's like the abbreviation of it basically. So I'll just write it out. And basically it's just a way to abbreviate like sine, adjacent, hypotenuse, and how it actually looks like is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and then tangent equals opposite over adjacent. Now to understand how this actually works, let's draw another triangle over here, right? Oh, sorry. Let's draw another triangle over here. Boom. Oh, that's a horrible one, sorry. Yeah, I suck at drawing. Another triangle here. And they're asking us for, let's say, ABC. And they're asking us what's the sine of A, right? So the longest side is always hypotenuse. So in this situation, the hypotenuse will be here. Now, how opposite and adjacent work is that adjacent will be the one next to it, as I like to think about it. So adjacent will be this one. Opposite is the opposite side of the triangle. So in this case, the opposite of A, the green triangle, is this side. So what do we know with that rule? So we already know that the longest line of the triangle is the hypotenuse. And because in this equation R, the closest, like the line given is the closer line, and it's not the opposite, it is adjacent. And based on what we know in SOHCAHTOA, the sine and cosine we're like using in this situation is cosine. So we gotta look for an angle in cosine where it equals, where now we plug in A and H, would be 5 with the square root of 5 over 10 with the square root of 5. Now we can cancel out the 5's because they're multiplying, and that's just like radical 5 over radical 5 equals 1. and then we're left with 5 over 10. And we can even simplify it even more by making it equal 1/2. So the actual equation, we're actually looking for an angle, which is r, or in cosine, where cosine of an angle equals 1/2. Now the easiest way to figure out the answer is memorizing your unit circle, because your unit circle is, in my opinion, the best way to figure out how to solve a question like this the easiest way. And once you know the unit circle and know the points, it basically just, or you can use a calculator, but if you know your unit circle, you already know that it's 60, which is your answer, because if you plug in cosine of 60 in a calculator, you're gonna get 1/2, because in the unit circle, in the point is 1/2 with radical 3 over 2, because of the unit circle, not because of the calculator. But you can use that calculator, but the unit circle is, in my opinion, so much easier, and that is our answer basically. So what I'm trying to say is that there's many ways to solve a question like that. You can use a calculator, but if you know your unit circle, you can solve the question like really quickly once you figure out you're using SOHCAHTOA, like if it's hypotenuse or adjacent, and it's pretty simple from there. Let's do a circle question now. Okay, the question asks the following: the given equation represents a circle in an x and y plane. If parentheses x comma -5 is a point on the circle, what is the possible value of x? So what do we know so far from the question that they're asking you? We already know that there's a point x -5, and because -5 is a y value, we already know that y with the parentheses equals -5, but we don't know the x value for that piece. Now we know the center of the circle is 7, -5, because anytime that they give you two numbers and this formula, which this is the circle formula, it's always the opposite. Like for example, let's say the middle is 6, -5, and we place these numbers in this equation, or the formula, sorry, we will have x plus 6 squared plus y, oh, I messed that up, sorry, plus parentheses y plus 5 squared, which equals the radius squared, but we don't have a radius. So let's say the radius equals 4, we will have 16. I messed up here, sorry. Wait, this will be negative, right? So that's why you already know that's the center. But they're asking us what is the possible value for x. So what we can do is plug in the y value that we're given right here, -5, in order to figure out the x value. So we plug in the y value into the theorem or the equation. We will have x minus 7 squared plus -5 plus 5 squared equals 16. Now let's simplify it. We have x minus 7 squared parentheses plus -5 plus 5 equals 0 squared, and we still have 16. Because anything is 0, squared is 0, we can cross this out, and we're left with x minus 7 squared, which equals 16. So what we can do is do the square root on both sides, because the square, oh, I messed up. We can find the square root on both sides, because 4 times 4 equals 16, which shows that 16 can be squared by two numbers that are the same number. So we can find the square root on both sides. So, oh, I don't know why it's doing that. So both these two cancel out, and then we're left with x minus 7. The square root of 16 equals 4. So you have x minus 7 equals 4. We have 7 on both sides. Let's find our x value, and the answer equals x equals 11, and that is our answer. Let's do our final question. And it asks the following: in the figure below, lines C and D are parallel, and ray A is perpendicular to line B. What is the value of y? Now, we're looking for the value of y over here. And we're given that there's an angle 55 and it's a right triangle. So we can already assume, let me make this in a different color, let me make this smaller. So we can already assume that the right triangle over here is 90. And at this angle over here, if we do 90 plus 55, equals 5, and then 9 plus 5 equals 145. And because in a triangle, which is this right over here, in a triangle, it always equals 180. So we do 180 minus 35. Oh no, sorry. If we do 180 minus 145, we get 35. So that is our answer over here. Now this looks like a lot of lines intersecting with each other, but it actually isn't. We're given from the question that line, oh, that is huge. We're given that line C and D are parallel with each other. So what does that mean? Well, that basically means that the interior angles on both sides equal the same. So to understand that, so because this is 55, every time that you have an angle, like let's say this is 60, the opposite of it, which is down here, will be 60 as well. So in this situation, if we have 55 on one side, this other side, which is over here, will equal 55 as well. And now, because they're both parallel, they also have the same alternating interior angles, which basically means that this side and this side also equal 55. So if both lines are parallel and you have the same angle, interior angle on one side, you're gonna have the same interior angle on the other side, which is called alternating interior angles. So now that we know that once we have 55, we have 90, and we have y, we can look for the y value. Now we know in the straight line it always equals 180. So in order to find y, we need to do 55 plus 90. 90 comes from a right triangle, because a right triangle, the side of it is always equal 90, plus y equals 180. So we add 145 first. We add 145 plus y, which equals 180. And if we do y equals minus 145, we get 35, and that is our answer, which is the same thing over here, which leads to my other point. Now, we talked about alternating interior angles. So the other way that you can figure out the answer is that because they're alternating and interior angles are basically the same, if 35 is up here, this angle as well, which is right down here, will also equal 35. So there's two ways to figure out the answer. You can use a 55, or you can solve for the right triangle, get 35. Let me reset everything over here. You can find the right triangle, understand that it's 35 over here and 35 on the other side of it, and because they're parallel, we can assume that y, because of the alternating interior angle rule, this is 35 as well. So there's two ways to solve this question, and now that you know.